Alright guys, hopefully this video reaches you in time. I hope it doesn't look too weird. So we're going to talk about polyatomic ions. Now the one thing you need to know about polyatomic ions is basically the atoms that you have been dealing with when naming compounds. Let me just give you a few. For example, you have NO3 minus, OH minus. You've been also seeing probably SO4 2 minus, etc. Right now you're looking at me like, what are you talking about? Okay, you've been naming compounds and formulas in class, but you've been looking at formulas that look like this: KOH or MgOH2. Okay, now basically these compounds are formed due to the fact that these guys exist. Now, what are polyatomic ions? They are ions that form from metals and nonmetals, okay? They exist usually in a solution, okay? They're in an aqueous solution, and they have a distinct charge. That's why here, this works because potassium has a positive 1 according to the periodic table, and OH overall has a negative 1 charge. Same thing here. Magnesium has a positive 2 charge according to the periodic table. OH has an overall negative charge, but you need 2 of them to counterbalance this. Now, why do you need to know these? The reasoning is basically for the naming, okay? Each one of them has a distinct name. For example, this is called nitrate. This is called hydroxide. And this is called sulfate. Okay? You cannot name compounds without knowing the names of these guys. Now, I'm going to provide you a table on Edmodo that will help you identify these. Okay? Let's put some to practice real quick. So first thing you got to do is identify which one is the cation, okay? Here, potassium is our cation. It's the one that's positively charged. But it has a positive 1 charge, and there's 2 of them, okay? CrO4 is going to be our polyatomic ion, and because there's 2 times positive 1, an overall charge of positive 2, that means that this polyatomic ion has to have a charge of -2. Now, what is the name of this polyatomic ion? You're going to have to look at a chart. Now, the chart looks very distinctively. Let me see if I can find one real quick. Well, I couldn't find one very easily, but if you guys see right here, they look like those, okay? Now, I don't know how close I have to get it. Now, they look like that. The name of this one is chromate, okay? When you are naming a bond between a metal and a polyatomic ion, we are going to name them the same way we name ionic bonds. So this is not going to be dipotassium, it's just going to be potassium chromate. And again, this name comes from the polyatomic ion. Notice how here we don't substitute the name with I. We leave it as it is. Let's have another one. Okay? MgNO3 2. Okay? This, as I said earlier in the video, is nitrate. So the name of this is magnesium nitrate. Okay? Again, we find this in the chart that I have provided to you. So make sure you download that first. Okay? Let's do another one. NaOH. Okay, this is a +1. It is sodium. This is a polyatomic ion with a -1 charge called hydroxide. And that's what it'll stay as. That is the name of this compound. Okay? Alright, now, what if you are given the name of the compound and you have to do the formula? Well, let's look at that. Let's say, for example, they give you potassium permanganate. Okay? We know what potassium looks like. So what we're going to do is we're going to find elemental potassium and we're going to add the oxidation charge at the top, the charge on the periodic table. So it's going to be K +1. Then we're going to find the polyatomic ion permanganate. Okay, again, you refer to the chart. Okay, this is not the chart I'm giving you. I'm giving you a similar one, but you refer to your chart. And permanganate looks like this. MnO4 -1. This entire polyatomic ion has a charge of -1. So -1 and +1, they work. So the whole formula looks like this. KMnO4. Okay, and that is potassium permanganate. Okay, let's do one more. Let's do, I don't know, magnesium sulfate. Okay, sorry, I wrote the formula. All right, so magnesium has a charge of Mg2+. Look for the sulfate ion, and sulfate looks like this. SO4 2-. Again, SO4 completely has a charge of -2. +2, that is your formula right there. Okay? Now, how would you recognize if something is a polyatomic ion? Look for these clues, okay? They end in ate or ite, okay? They also, some of them contain oxygen in third compound, okay? So what I mean is like KMnO4, this is your third compound, or MgOH2. This is your third compound, but you know, you see O right there too. Okay? Other things, basically subscripts. These guys right here. Okay? Well, thanks for watching. I'm going to upload this video, and if you have any questions, comment below.